Just look at that mythical mountain, Mount Olympus.
Most likely is one of the view of the early men. So I feel like traveling back in time when I see Mount Olympus from the sea.
For thousands of years, this massive has impressed mankind. In Greek mythology, it's here, on Greece's highest peak, that the 12 gods of Olympus reside. Originally, Olympus, literally Ol Olympos, would have meant the ever-shining. In the Iliad and the Odyssey, Homer praises the brightness and sparkling snows that eternally clothe the sacred mountain. For the Greek geologist Mike Stelis, these evocations are clues to the climate in antiquity, when the cult of the Olympian gods thrived.
It's our secret desire to try to ascribe some meaning to the ancient Greek mythology. With our study now, we want to test the hypothesis that maybe during the Homer times, probably due to a climate perturbation, there was a small or a big glaciation period that made the mountain shine even more.
To reconstruct the history of Olympus's climate, Mike will explore its summits in search of information buried in the snow and ancient ice.
This cave is a little treasure, scientific treasure. Potentially, it can provide a very unique archive of past climate variations on Mount Olympus over the last millennia. I mean, we don't know how far back we can go in time, but this is one of the main challenges of the ongoing research here on Mount Olympus Alpine Zone.
Time is running out. With global warming, the ice is melting and a whole part of the climate's memory may disappear forever. For the first time, experts will join forces to unlock the secrets of the ice.
The first guy in the history of Greece that you're taking an ice core from Greece. Yes.
And unveil the mysteries of Mount Olympus.
That's already 33 pounds, and I still have to load up my skis, boots, crampons, ice axe, my banana, and the flasks.
It is the end of winter. The ascent being prepared is crucial. It marks the start of an unprecedented scientific odyssey on Mount Olympus. The mission's first objective: to collect snow that has fallen this season at an altitude of 8,800 feet. To understand the ice of the past, the scientist must first probe the present snow.
But for me, it's not only the bread that I carry. I have a little bit of climbing equipment, which is necessary to cross the exposed reeds. And I have some scientific equipment because this ascent is part of a project that I participate with colleagues from Romania and from Norway and from Greece. The project is Paleolus project. This time I'm climbing for science.
Let's hit the snow.
No road leads to the summits of Olympus. Mike and his teammates begin the 7.4-mile trek to the refuge on the Muses Plateau.
Well, Mount Olympus is very close to civilization, but very, very far in the same time. So the whole hike is it's a long one, it's a very demanding one. I just think that with all this weight, we have to climb 2,000 meters of vertical elevation gain. And normally people do it in 2 days.
Halfway up to the highest peaks, a tree struck by lightning warns the men. Beware all those who dare to venture into Zeus's kingdom.
And here the master of the elements is Zeus. And it holds the key of the meta, of the weather, and of many other things.
In mythology, Zeus used lightning to overthrow the Titans, the giants who were ruling over the world.
And at the ancient people's mind, it was really evident that there is something wrong going on up there.
Zeus settles atop Greece's highest peak. He becomes the master of this new divine order, that of the Olympian gods.
The scientific explanation comes from the geomorphological setting of Mount Olympus. Just imagine now, today, in the coastline, we have 18 degrees, and up here we have 0 degrees. And further up, in 2000, in the Plateau of Muses, or in the higher summits, we have minus 8 degrees. So this contrast, the temperature contrast, and then the contrast in the slope of the mountain, creates this unique phenomenon, and that explains the very high thunder activity around Mount Olympus. It is the highest among many other mountains of around the Aegean Sea, the North Aegean Sea. I have been punished by thunder because I thought I could just push through a very violent summer thunderstorm. And I got knocked back down, ending up leaving my backpack and running anywhere I could run. And yeah, this was not the only time, unfortunately, because sometimes you don't learn from your mistakes.
The wrath of the gods never deterred Mike. Since the age of 8, he has been climbing mountains. He's even conquered Everest. He has often come up against the violence of the elements and the bite of the cold. In the Himalayas, frostbite claimed the end of his nose.
Mount Olympus is my home. I've been climbing here since a very young age, so I've been around for 40 years. And it's a place where I've done many firsts. First ascent to the summit of Greece, first time that I got the desire to study geology. Actually, this is why I studied geology, because I was coming here as a very young kid, and I had many questions. First time I thought that I became an alpinist, first time that I got turned down by the mountain, ending up in a wheelchair with 2 broken legs. First time I fell in love, and first time that I'm able now to launch some big-scale research on the alpine zone of Mount Olympus.
If the team ventures onto Olympus today, despite the harsh conditions, it's because every season holds its secrets. Before spring, snow accumulation is at its peak. Mike needs to take samples from the snowpack before it melts. To reach the Muses Plateau, the team will have to follow an exposed ridge 4,600 feet long. At this very spot, the legend of the mountain forbidden to mortals takes on its full meaning.
The snow is fresh. There are chamois tracks.
Once when it was really foggy, so you couldn't see anything, when whiteout, happens, it's really scary. You cannot even see your feet, so sometimes it's really challenging.
The exposure of these reeds, the feeling of air that you get when you cross the reeds, because you may slip on the ice and die, then it's a very good, very well guarded location to put the gods up there, and so nobody can access them.
Guys, be careful here. The cornice completely changed direction with the wind. The cornice can break, so watch out.
A final effort, and finally, the Muses Plateau appears. The sun is shedding its last rays. The conditions are polar.
What an adventure.
It is home sweet home after a very long day. Every time I have this insecurity that I forgot the keys, but apparently not. Oof. Okay. Oof.
Well done, guys.
Wow, it was tough at the end. Is there any fuel left in the stove?
There should be some. We'll have to put some more in.
Take this. I'm freezing. Is it lit?
It's working. It's all good.
You go back to basics. We feel a little bit primitive. By the time you unlock the door, the next thought is this gonna work? And by the time it works, then the world is good again.
With every sunrise, the emblematic throne of Zeus becomes the stage of a surprising phenomenon.
If you look carefully to the left, where the shade joins the sunlight on the left side of the rock face, you can see, if you look carefully, the two eyebrows and the nose, and this is the pareidolia that many people have ascribed to the face of Zeus. The etymology of pareidolia comes from the Greek para, parallel, parallelo, and idolo, which is the image. And in nature, there are many formations in the clouds, in the snow, in the rock, like we see here. So people give to these parallel images some divine features. That's how the myths are created. And even today, I mean, the myth is still alive.
Anyone who sets eyes on Olympus is taken by the magic at work here. Like the rainbow. In mythology, It is the trace left behind by the goddess Iris, messenger of the gods, when she descends to earth to inform the mortals. Iris, in ancient Greek, means the rainbow. The Muses Plateau is a geological curiosity perched 8,500 feet above sea level at the crossroads of the winds. In this immense basin, snow, pollen, and dust accumulate, treasures for science. By the end of this season, all this snow will have disappeared, and with it, precious information about air currents, their intensity, their origin, and what they carry. This is where Mike will carry out the first phase of sampling.
The history of the winter.
A glacier takes thousands of years to form. To grow by just a few millimeters, huge accumulations of snow are needed, which gradually become compacted. All kinds of materials are trapped within, creating strata in the snow and then in the ice.
180 centimeters of snow. Okay, this year I see this profile and I can see that was a period with Notiades, Sirocco south winds. And this is what I come here for. This is the most interesting part. It's a thick layer of Sahara of dust accumulation. Then the powder snow, the very soft snow came, dry snow came with Voriades, Boreas, with north winds.
The geologist wants to compare the composition of this snow cover with samples he hopes to take from very old, well-preserved ice elsewhere. These will only be accessible in summer, when the snow has melted and the slopes of Olympus are passable.
So the more modern data we have, the better we can look at the past. So these modern analogs, if we have a long compilation of years like this, they can help us understand when we analyze longer past climatic archives, like sediments or ice core or ice deposits. Then we can really fit them and see if they fit together. That's how we are able to reconstruct the climate in a good time scale, maybe annual or every 10 years, and understand better the changes of the climate, and then connect this to changes in the societies, and even more connect it in a more general way to changes in the myth and the human perception about the climate and the mountains.
The project was named Palaeolus, in homage to the myth of Aeolus, master of the winds. In mythology, he appeases or excites others according to his will. In antiquity, navigators had already identified the existence of wind patterns, varying in strength and direction according to the location, the season, the sunrise, or sunset. The winds represented essential figures in navigation and agriculture. Zephyrus, the west wind, embodies the spring breeze, while Boreas, god of the north wind, gives birth to snow. The snow has melted, and Mike is going to filter out the Saharan dust carried by the Sirocco wind.
Okay, done. Dust. I see dust. I cannot see more, but from the previous analysis, I know more or less what to expect in here. To find out the source of the dust, we look to two different things. First, different parts of Sahara contain different minerals. And second, we also measure the isotopic composition of the dust, because that's how we can even better fingerprint if it comes from Egypt, from Libya, or from Morocco and Atlas Mountains from the West Sahara. And these sources change also over time.
The analysis will be cross-referenced with satellite data to provide a better understanding of wind patterns on Olympus. This information will be vital to the rest of the project.
And this is why we collect the samples, to have a better, to have more representations of the different episodes over the last years. And this will be our modern analog to study the dust that was deposited in the past in the ice cave.
Among the major sites identified for the project is this extraordinary cave. At its heart lies an astonishing plug of ice, protected from the sun. Difficult to access, it has never been explored. He'll have to wait until summer to hope to approach it.
This cave is a little treasure, scientific treasure. Is very interesting because it's a small shaft that gets snow year by year that turns to ice. So it's the only archive we have, especially on this side of the mountain, that can host old glacier ice. This ice deposit that we don't know how, potentially it can provide a very unique archive of past climate variations on Mount Olympus over the last millennia. I mean, we don't know how far back we can go in time, but this is one of the main challenges of the ongoing research here on Mount Olympus Alpine Zone.
This is the next stage of the Paleoliths project, to explore the cave and probe the ice in the hope of finding strata that may have accumulated since ancient times.
Careful, there's ice.
Keep going, we're not stopping.
6 months later, the geologist is back with a ton of equipment. Some 15 scientists await Mike on the Muses Plateau, at the foot of the throne of Zeus.
There you are.
How are you, my brother?
Good, and you?
The mission brings together specialists from all four corners of Europe. They are cavers, archaeologists, geologists, all longtime friends.
We were waiting 5 years for these expeditions with a lot, many discussions. That we finally were here, and now we are so happy.
Yeah. We had this, the initial expectation it will be just only 4 or 5 of us, but now there's a nice group coming up, so yeah.
Everything started slowly, and now it's getting bigger. Yeah. Much bigger.
It's an avalanche.
Yeah. So
Science avalanche.
I've got it. What about you?
This goes here, doesn't it?
Where would you like it to go?
Does it matter which one is above and which one is below?
I think
We'll see.
We have altogether 10 PhD degrees here, and we cannot set up a dome tent.
created democracy, not tents.
Go, Hercules.
Well done.
The snow has disappeared from the landscape. But at the bottom of the cave, protected from the sun's rays and heat, the ice deposit survived.
What else do we have to take?
It's good for you.
Let's go. To the left.
We're in this together.
Here we go.
The approach is tricky, especially with a 22-pound generator on their back and dozens of feet of tubing to drill through the ice.
Hey, Yorgo. I'll take over from here.
The cave is an hour's walk away. Impossible to get there with mules. There's no path.
Your turn.
You got it?
Which way is it?
After that ridge.
Up there?
Yes.
How about we just see the...
Yeah, let's go check. We leave it here. Yeah. In 2 minutes, no more going. In 1 minute.
The slightest misstep, and you're in for a severe fall.
Christo, are you okay? Are you stuck?
We're making progress, but it's very difficult.
Watch out! Rocks!
Access to the cave is via a vertiginous 300 feet long corridor.
Wow, good stuff. I'm blown. I'm happy for two reasons, because we had a theory that is just confirmed regarding really science. The May-June rain eats the ice, let's say it like this. So because we had rains this summer, the theory is right, and the ice is not so much, so we can be closer to the ancient ice, because there is still snow, of course, but it's very low. So that means eventually, when we start coring, it's gonna go easier to hit the glacial ice.
It's nice.
All around the ice plug, there are deep crevices, which they may be able to explore.
Can you hold this? So I can go and check.
Yeah. Guys, just 1 second. 1 second. Just keep quiet.
How deep is it?
It's hard to say.
The stone landed on ice. Throw another one.
Because it has snow on the bottom, we cannot hear very well the sound of the rock. Usually, we throw a rock just to understand if it is deep enough or not.
Well, that was it. We're done for today.
Cheers.
Yamas.
Long day, good day. We rigged everything, and now what? So far, so good. So what?
We came all back. Today it was a good time.
Today, I mean,
Carrying the generator.
Double back. After 30 years exploring the summits and the rock faces and the alpine walls of Mount Olympus, it's about time to go down and see what's under the earth.
Now is the moment of truth.
now we're gonna discover the secrets of the gods and see what's under the earth, the realm of Hades. Hades was the god of the underworld, the god who reigned the dead.
Part of the team goes in search of the oldest strata of the ice.
Okay, see you.
I stay to the right?
They reach the bottom of the cave, 130 feet below the surface. The cavers are worried. The ice is melting before their eyes.
The moment we broke this, immediately water started flowing here. So it means that there is liquid water flowing inside this. So I'm not optimistic at all. I think we should leave. It's pointless. Look how much water is coming out of this layer.
This sediment layer may be contaminated. Difficult to collect valid samples here. To obtain the maximum amount of reliable data, there's nothing better than taking a core sample from the heart of the ice block.
Here. Take the next. Okay. Let's turn the generator on.
Maybe again there is power drop.
How this used to work.
Okay. The same thing. Who was the god? No, there was no god of electricity. Yes. So there is no one to pray to.
Who was the god?
We should pray.
The god of crafts, Hephaestus.
Yeah. He's on the other side of the mountain.
We have power in the cave. We have power in the drill head, but it doesn't work.
But we cannot drill.
So it seems that the power we got is not enough for some reason.
The gods have decided there will be no drilling today. Back at the refuge, Mike receives an unexpected visit from Konstantinos Vasilikakos.
Hi, Mike.
You're here. How you doing?
Great. Happy to be here.
Are you going to the summit?
Come bivouac with me.
I can't. I have to dig.
Oh, that's too bad.
Welcome back.
This astrophotographer, a regular visitor to Olympus, is this time preparing a unique expedition with Mike's help.
Tomorrow I think it'll clear up. It's blowing toward the west.
The wind's gonna blow at 12 miles per hour tomorrow and the day after 18. It's good for time lapses.
Konstantinos will attempt to bivouac for an entire night to capture the stars from Mytikas Peak, behind the throne of Zeus. It's the highest summit in Greece. According to Homer, the gods took up residence here, in the clouds, hidden from mortal sight. It's not the photographer's first attempt. Konstantinos nearly burnt his wings trying to get closer to the gods. That was in 2014 on his first ascent.
There was a storm in front of me. To stay calm and chase away the terrifying idea that I could die at any moment, I started taking photos. I set the shutter release and stood at the top with a light. And I captured this unique image. Basically, Zeus said to me, "I'm going to test you, and if you come through, I'll give you the whole universe."
Ever since, Konstantinos has been on intimate terms with the heavens, tracking down their divine manifestations.
This place is the Pantheon, the home of the gods. There's nothing higher except my dreams, my ambitions, and all the things that I want to experience.
Konstantinos is nicknamed the Star Boy. Tonight, he has a rendezvous with the Milky Way, an iconic element in Olympian mythology. At birth, Hercules, illegitimate son of Zeus, is not immortal. To become so, he is placed at the breast of the goddess Hera while she sleeps. When she awakens, she realizes the trick and rejects the child. Milk spurts from her breast.
And the milk fell on the sky, giving birth to the Milky Way. Galaxias means the path of the milk. I think it's so romantic to capture the movement of the galaxy from the summit. It's the quintessence of mythology, astronomy, and photography.
Changing the plug to see if some of the cables are destroyed.
That's the common way with fieldwork. You have to expect the unexpected, in a way. Yeah, might be the storm coming in, or tents getting ruined, or it may be snow covering the openings, or it may be that.
Start it!
You see, when you want.
Drill, baby, drill!
Hades, here we come. Hold the cable.
Might be ready for you.
To reach the ancient ice layers, scientists must first go through the snow cover. Each core is inspected by Aurel Persoiu, an ice cave specialist.
Grass, leaves, maybe needles from the pines outside. Sometimes we find bat droppings, but this is not the case here because there are no bats in this cave. So anything that is organic and it was alive outside the cave, it's good for dating.
One drill after another, and the core is getting harder and harder. The deeper they go, the more the core head gets stuck. They must extract it quickly before it freezes.
Up, up, down and up.
And a dozen drillings later.
Ooh, have
What?
ice?
Mike is excited.
This is the layering.
Yeah.
This is definitely layering.
You see, this was the former surface. Look, look. Ah. So it seems that we started to get into the layered part of the ice mass. And you can see that there is a clear demarcation layer. On top of it, there is a bit of dust. And there is some pieces of hopefully organic matter. And we will get this piece of ice for radiocarbon dating. It's better than we were expecting because we were not, at least I was not expecting to get organic matter so close to the surface. And yeah, it's a nice surprise. Okay, so this is Zeus 1-1. I can't stop smiling, sorry about this. Okay, yeah. I want to have a thought, like, it's really like a baby.
The first guy in the history of Greece that you're taking a nice call from Greece. But it's true, yes.
The time for analysis begins.
That would be the best. So I think it's only just different snow events.
Within the same year, huh?
Yeah.
Wow, that's gonna be Paleolus reconstruction.
On first observation, this small sample seems to concentrate a whole year's worth of old snow, a boon for climatologists.
Ooh.
Yeah, that's it.
Makes it even more precious than we thought. Because usually from previous experience, we thought every layer is 1 year. But if within one calendar year, we can see differences in the isotopes in the chemistry, December snow, March snow, April late season snow, and we know when we would expect also some dust. Usually it comes in the spring. So that's even really much higher time division than we initially thought.
So it's better than expected, actually.
Yeah.
I mean, it's
Yeah, and
still bubbly.
still bubbly.
Good. Snow.
The samples will be sent to specialized laboratories. In a few months, the climatologists will know the age of the ice and its composition. On the last day of the expedition, the team embarks on the final stage of the project, the exploration of the north side of the massif, the valley best sheltered from the sun. They hope to unravel the mystery of the eternal brightness mentioned by the ancients.
The goal of today's mission is to discover the glacier's legacy on Mount Olympus.
The valley is called Megala Kazania, Greek for the big pot. This is one of the most difficult sites to reach on Mount Olympus. Huge 3,000 feet high cliffs make the area almost inaccessible. It will take the team over 3 hours to reach the bottom of the circus. The scientists lay electric cables over the terrain. The cables are connected to probes. These probes use electrical current to identify the various materials that make up the subsoil.
So in this site, we want to see if there is buried ice underneath this scree, or permafrost, or stuff like that. So as you can see now, there is no glacier in this very nice glacial cirque, only some small snow perennial patches. So usually in this type of environment with a lot of scree, it's possible that ice to survive for tens of hundreds of years after the glaciers disappeared. But we'll see. This is the first time someone measures here. So it has to be a crazy team to do this. And if we found ice, it will be the southernmost permafrost or buried ice in Europe, actually. So there is no report for permafrost at a lower latitude in Europe so far. For us, for geoscientists, this is treasure, you know?
The sensors are connected, and the first information appears.
So in this first part, I would say this is an ice anomaly. And they are immediately near the snow patch. I think this is what Mike wants to see. So it might be some buried ice up there. But we will be sure after we will make the processing.
A few more minutes of waiting. Meanwhile, Mike has spotted a rock that will reveal some valuable information.
We know that there was a glacier here because we see this runnel. So this can be created only by running water. So only ice could bring water here. A lot of water to start eroding the rock like this. A glacier here on Mount Olympus would mean that in Athens it would have been cold. Some settlements would have been abandoned because they could not resist the cold, even in the lowlands. So we're trying to see if during this period there was an episode of glaciation on Mount Olympus, which might as well correlate with archaeological data or texts or other like...
Is Mike hearing? Over?
Yes, yes.
Mike, we not only found ice underneath the surface, but we found surface ice.
Okay, I guess that's very good news, huh?
Yes, that's brilliant news, and quite unexpected. Perfect.
So the glacier is still alive?
Of course, we were smelling the ice before.
They found the glacier, they found the ice. Yeah, it's just buried under the blanket, so it didn't quite disappear yet, but you know, it takes a little more effort to reveal the secrets of the gods. So I guess now we have to do another profile and start digging to touch the sacred ice of Mount Olympus.
Mike sets off without delay to discover it. Hidden beneath a thin layer of rock, the glacier reveals itself to him.
So it's been a very exciting moment, kind of under the blanket, revealing the ancient glacier ice, because this ice is very, very, very hard. It's an old ice. It's a revelation for me. Now, by analyzing this for the isotopic composition, we will know the source of the water that this ice was formed. Was it from the Mediterranean? Was it from the Atlantic? We're also gonna find out what's in there. Is there dust or is it just pure ice? And the age of this ice. And compare the findings with the ones we have from the ice cave.
Scientists have probed 10 acres, and the discovery is colossal. The ice is at least 32 feet deep.
Under where we're standing, there is a lot of ice. As long as it's down there, I feel better human today. Mount Olympus still shines, but the white color has been buried under a blanket, and maybe it's the last act of the gods when they got unhappy with the modern humans. They just buried the secrets under the rocks and kept the ice for themselves and just disappeared.
2 seasons after the project began, Palaiolus is beginning to deliver its results, enriching the existing database about the region. Little by little, the puzzle of the ancient climate is being completed, and the story of Olympus is becoming clearer.
You know, science never ends. So to our big surprise, we started dating the ice in the ice cave. So the real ice starts at 500 years ago. So these are the relics of the little ice age. Around 5,000 years before now, we observe a change and with much more moisture coming from the Mediterranean and the Aegean Sea. And this coincided with a period of colder climate in general in the region that probably gradually gave birth to the glaciation that we observe here just on Mount Olympus around 2,800 years ago. And this period coincides with the Homeric poetry and the first description of Mount Olympus as the ever-shining mountain. People got more inspired watching during the summer months this white apron below the main summits of Mount Olympus. We just opened a small window now and we took the courage from our recent results. So I think we're in the beginning of a new scientific odyssey. We're gonna look in more detail many different things and try to get out all the wealth of climatic and environmental information we can find here.
One thing's for sure, as long as the ice survives on Mount Olympus, Mike Stillis will be back at the bedside of the gods.